Hi students, today we are going to take a look at some of the skills you will need to work with fractions and specifically adding, subtracting, and multiplying fractions. And today we're looking at mixed numbers and improper fractions. Students will be able to model and write mixed numbers and improper fractions. All right, so I just want to review what those two things are. What is a mixed number? What is an improper fraction? So a mixed number is a combination of one or more wholes and then a part. So in a mixed number, you're going to see a whole number, such as 2, combined with a fraction, such as 1/3. Mixed numbers are always going to be greater than 1 because we will have, at minimum, 1 and then some kind of fractional amount, maybe 1/10. So 1 and 1/10 is another example of a mixed number. All mixed numbers can be rewritten as improper fractions. An improper fraction is a fraction that is worth more than 1. Well, wait a minute, how can a fraction be worth more than 1? Because the numerator or top number is greater than the denominator or bottom number. So an improper fraction is top heavy. The top or numerator is greater than the bottom or denominator. That means that improper fractions are worth more than one whole. All improper fractions can be written as a mixed number. So let's take a look at how we can model mixed numbers and improper fractions and write them. In our first model, and again, please assume that all of the pieces in my models are in equal size. I'm drawing it freehand, so they will not be perfectly equal, but we're pretending that they are because we know that fractions have equal size pieces. So here I have, we can call these 2 pizzas. And the first pizza will be completely shaded in. And we can say that that represents the entire pizza being eaten. So here is our first model. And the second model is showing one part shaded in. And we can say that one slice of that pizza was eaten. So because we are dealing with more than one whole, we can write this both as a mixed number and as an improper fraction. So let's figure out what this is equal to. In my first model here, I have the entire amount shaded. I have one whole shaded in. In this model on this side, I have one piece shaded in out of how many equal parts? 1, 2, 3, 4, 5, 6. So this model shows 1/6 or 1 out of 6. If I combine those two models or add them together, I have a total amount of 1 and 1/6 shaded in. This is a mixed number. It's a mixed number because we have more than one whole. We have one whole and some more, 1/6. Now I can also write that as an improper fraction. And to do that, I need to count up all of the pieces that are shaded from all of my models. So let's count all of the shaded pieces. Starting on this side, I have 1, 2, 3, 4, 5, 6 shaded pieces. And remember, it was cut up into 6 equal pieces. So I have 6 out of 6, which is how I got my whole. Now let's go to the second model. I have one shaded piece Again, that was cut up into 6 equal pieces. So I have 1/6. So how many total shaded pieces are there? Let's count. I have 6 plus 1 more, or 1, 2, 3, 4, 5, 6, 7. I have 7 shaded pieces out of a total per model of 6. Now notice I did not add the total pieces together because that is just representing the number of equal parts in our model. Each of these has 6 equal pieces. So my denominator is going to remain 6 throughout all of this. When we wrote it as a mixed number, it was 6. And when we write it as an improper fraction, the denominator remains to be 6. So this model shows 1 whole and 1/6, which is equivalent or equal to 7/6. They are the same amount. Let's do another example. This time I'm going to use a fraction strip. Again, please always assume that my pieces are equal. We're pretending that they are, even if they don't look like it. As I'm drawing this, I want you to start thinking about what you see. All right, so let's look at this model. In this model, I have 3 shaded out of 3 total, or the whole thing. In this model, it's the same. I have 3 shaded out of 3. That's another whole. And down here, I have 2 shaded out of 3. So I have 2/3. To find out all of this, I would combine or add 1 plus 1 equals 2 wholes. And then the fractional amount that's left over, I have 2/3. So this model is showing 2 wholes and 2/3, or 2 and 2/3. Can we write it as a fraction? Yes, we can. So as a fraction, I can keep the same denominator because they're still cut up into 3 equal parts. And next, I just want to count all of the pieces that are shaded. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 shaded pieces, and each model was cut up into thirds, so we can call that 8/3. Now, I know that might look goofy to you because you're not used to seeing fractions where the numerator is greater than the denominator, and that's okay. It's just something new that we're learning. In 5th and 6th grade, you're going to see these types of numbers represented mostly as mixed numbers. As you get into the older math years, you're going to move more away from mixed numbers, and you'll represent mixed numbers as improper fractions a lot more often. But for now, mixed numbers will probably make a little more sense to you. We can visualize 2 and 2/3 a little bit easier than we can 8/3. So now that I've shown you how to do this with models, I'd like to show you how to change from mixed to improper without using a model. So there are a few steps to do this, and I'm going to use this current example to prove to you that it works. So step 1, when we have 2 and 2/3, and this will always be the same going mixed to improper. Step 1, take your denominator and multiply it by your whole number. So our step 1 is to take 3 times 2, and that equals 6. And we hold that 6 in our head because our next step is to take that product and add in your numerator. And 6 plus 2 gives us 8. I call this the circle-y thing. It's really, there's no technical term that I use. I just call it the circle-y thing because we start at here at the bottom and then we circle our way around kind of like a clock. It's called clockwise, and we end at the top. And then we always keep the denominator. So what we got after we added the 8 is our numerator. And then we keep the denominator, 8/3. Well, wait a minute, that's what we got when we used the model. And think about why. If we take our first step, 3, the denominator, times 2, the whole number, that's because we had groups of 3 twice. We have 2 groups of 3, 3 times 2, and that got us our 6 pieces. But then we add to that 2 additional pieces. So that circle-y thing is just counting up all of your shaded pieces. 3 times 2, 3 times 2, plus another 2, plus another 2. And we keep our denominator. So when you have a mixed number, you of course could always make a model if you're good at that and if you want to. Or you could do the circle-y thing, starting at the denominator, multiply it by the whole number, add in the numerator, keep the denominator. All right, I want to show you one more without the model. Let's take the fraction 5 3/7 and write it as an improper fraction. I think I just called this a fraction. Let's take this mixed number and make it an improper fraction. Of course, you could draw a model, but that would take some time, and it might be hard to draw sevenths. So here's our steps. First step, we want to take the denominator, 7, and multiply it by the whole number, 5. First step. 7 times 5 is 35. Next, I want to add to that the numerator. So I want to take that 35 and add to it 3 more. And we get 38. And that becomes the numerator. Starkey, no. So I know my answer will have, 38 as its numerator. And then the last step is to keep the denominator the same, which is 7. So to write this as an improper fraction, we would have 38 over 7, or 38/7. That is equivalent to our 5 3/7. They are equal to each other. If you drew a model to show 5 wholes and 3/7, and all of those 5 wholes were cut up into 7 pieces, you would have a grand total of 38 shaded pieces in models that were cut up into 7ths. All right, I want to show you one more thing. I know this video is a little longer than normal, but I'm really putting 2 skills together. I want to show you the opposite. Let's say that you have 3. No, I lied. We don't have 3. I'm going to show you a model, okay? And in my model, I have that represented, okay? So before I do my mixed number, I want to start off with the improper fraction. To do that, I'm going to count each and every one of my shaded pieces. That will be my numerator. 1, 2, 3, 4, 5, 6, 7. I have 7 shaded pieces. And each of the models was cut up into 2 equal parts, or halves. So that shows me 7 halves. Well, how can I turn that into a mixed number? Well, in my model, I can just count 1 whole, 2 wholes, 3 wholes, and 1/2 of another. So 7 halves equals 3 and 1/2. When you're going from improper to a mixed number, it might be helpful to draw out the model. Otherwise, without a model, you need to do some division. I'm going to take the same 7 halves. To figure out what this would be as a mixed number, what we're thinking of is back to our last chapter where we learned that fractions are really division problems. And this is really 7 divided by 2. And if we figure out 7 divided by 2, we will have our mixed number. So how many 2's can I take out of 7? 7 divided by 2. Let's count. 2, 4, 6, 8. 8's too high. I can take out 3 wholes because 3 times 2 equals 6. And what's left over? 7 minus 6 is 1. And to write that as a fraction, I put my remainder as my numerator, my divisor as my denominator. 3 and 1/2. That's what we got when we used our model. Now, for those of you that are struggling with long division, drawing a model would be probably a lot more helpful at this point until you're better with this division. You could also kind of approach this mentally by saying, how many 2's can I take out of 7? 2, 4, 6. Aha, I can take out 3 wholes. And then what's left over? If I pull that 6 away from my numerator, what's left over if I took out 6? 1, and I'm going to keep my denominator. So there's another way you can approach that problem. All right, this video is long enough as it is. We will do more examples in class. If you have any questions, let me know. Thanks, and I'll see you next time.